Our next speaker is Ian Matheson. Ian and his wife Carly and brother Scott, sister-in-law Jacqueline, and mom and dad Bob and Helen Matheson farm near Embro. They operate 800 sow power out of Finnish and about 1,000 acres of their own land, plus poor Ian drives all over the place all summer long with his high-boy sprayer, helping other people out. Last year or the year before, they bought a tire inflation system because of the weight of the manure spreader for all the manure that they have to handle. So for all the advantages that manure brings to their operation in terms of the whole life cycle of that farm, it also causes problems in terms of the compaction. They were trying to address that. And so with the manure and everything else, they continue to be in a conventional tillage scenario for the most part, but he's looking at other ways to mitigate the compaction, and Ian's going to talk about that. So, Ian?
Is everybody able to hear me okay? Good? Okay. So thanks, Ian. He asked me to do this a couple months ago, and I've never done something like this before, so this is kind of new. So, so we've got a livestock row crop based farm, and we're in the north. Does this work? Here we go. So yeah, I think he sort of ran through most of that and covered that for us. 1,200 acres of crops, corn, soybeans. We've been growing winter wheat as well as winter barley. We're switching back to mostly barley, and I'll sort of touch on that as to the reasons for that. So we're in the northwest corner of Oxford County. I've spent most of this week in London with a group from out west, and the dynamics are very different in Oxford County versus Saskatchewan and Alberta and everything else, yet they're very similar. Everybody across the country's got the same issue. Competitive land is their unique problem, and everybody has the same unique problem. So we're quite rolling right in the area that we're in. Light sandy loam soils, mostly systematically tiled, although we do have some gravel bottom stuff that gets along quite well, just sort of as is. Typical crop rotation: corn, soybeans, winter cereal. When we have the winter barley, we actually double crop back in with soybeans right afterwards. The corn crop, about 80% of it is able to get spring manure, which is a challenge. You want to get the manure out as fast as you can to not give up bushels planting corn, obviously. And some years we've been burnt. You think the ground is fit to go, and come June, obviously it very wasn't fit to go. So that was, we started looking for ways to address that. So, that's what you don't want to end up seeing, is those waves of the tanker tracks showing up later on. So the nature of tanking manure obviously is you're pulling off the road close to where you want to spread, and you always end up with many tracks across the field. So controlled traffic, that type of thing is a great scenario, but I think it's got some definite challenges with the manure. So we were weighing out some options as to what we were going to do to mitigate our compaction issues. So an obvious idea would be dragline. We are spread out over, say, 10 to 12 miles to some of the furthest fields. So those ones get very difficult to dragline without involving trucks to get it there and everything else. So we like to keep the idea of sort of one system that fits everywhere. So we started looking at the inflation-deflation system. It adds on our existing equipment. There was some funding available, which made it extra sweet. Now the downside to putting it on our own is in the spring we generally rent some neighbors' equipment as well. So we'll run two 6750 gallon tanks as well as a 12,000 gallon quad. So the way that we've sort of mitigated that is our own with the tire system on. sort of strategically send it to certain areas of the fields where risk is higher, as well as the larger tank, long rows, get it in, get it out kind of thing as well. So we've been quite happy with the system. It's very simple to use. We do run it, all seasons of the year. We're using that switch box and dropping the air and increasing it as well. So we're running 50 PSI on the road and dropping at 25 PSI in the field. And we did notice, I haven't got concrete numbers, but fuel savings is there. We do quite a bit of road work with it. And, they claim 50% more footprint in the field, so that's quite significant. So in the cab, it's just a little 8-inch screen with a toggle switch on the side. Anybody can jump in and understand it very quickly. And that's sort of a close-up of the screen. Again, it sort of tells you what you're at as far as pressure goes. And so it shows it's at 49, the tank's at 138. It takes a bit to get the system back up to pressure, but usually by the time you need to be back up to pressure when you're filling at the barn, you're back up to that stage before you're heading back out with full load. So there's a bit of a video here. This isn't our tank. I don't have any videos of it.
The tractor and the tanker are now stuck. We've dropped the air pressure in the tanker tires to 14 psi in hopes to create a larger footprint and back this tanker out of this mud hole. No. Isn't that amazing? This run is in an even wetter part of the field where we previously got stuck. To show the difference when we reduced the pressure in the tires to 14 psi, as you can see, the tanker drove right through the wet spot without any problem. Isn't that amazing? That is pretty amazing. This first track we're showing was made with the tire inflated to 25 psi, and as we can see, it sunk about 14.5 inches into the ground. This track was made right beside the previous one, but with tires deflated to 14 psi, and it sunk a little over 6 inches into the ground.
Also, another advantage is that the tires are actually being used for what they're designed. They inflate, deflate to the speed and weight that they're designed to be used for. To our best of our understanding, the systems out there, they're mostly 2 minutes or longer to deflate. And that makes our system very appealing.
You can see it dropping in pressure there, and that's on cement, it really shows it very well. So I think that in that field situation, that's a do not try at home scenario. If you're seeing that and you're only dropping 7 inches, go find something else to do. So yeah, that's sort of the scenario quite often. That was through a dirty back window of a tractor, obviously. With multiple tanks, running it on one. Ideally, we would be running the system on 3, but the other farmers haven't made the commitment to putting it on. I know one is seriously considering it at the time. So this was kind of a neat picture that we sort of stumbled across when we were doing some UAV work with before side dressing time. We're looking at doing some variable rate nitrogen, and what we actually a pointer? There it is. So barn's obviously here, running it off the road, unloading and spreading that way. When I got this image back, the first thing I pointed out to them was, you can see our spread pattern, exactly where everything's driving. And the guy that I was dealing with thought, no, I thought those were all tile runs, but it was actually, found it neat how it showed up. But The really interesting thing is I was up on an elevator leg overlooking this farm a couple days before this image was taken, and I thought the farm looked great. I mean, consistent across everything. But then these lines are showing up. What those actually are is the runways back to the barn when we were empty. So when we're spreading manure, you know, turn and burn kind of thing, right? But we try to always take the same path back to sort of minimize that damage. So I just found it very interesting that it showed up this clear through the NDVI image, but to the naked eye there was nothing there at all. So next. Okay, so just some other things in our operation. We do use GPS to sort of, it's a hybrid to the CTF, obviously. We want to minimize the passes across the field, obviously. Large flotation tires where we can. Run 650 duals on our combine. So following winter wheat, our sort of program is 80 pounds of oats, 2 pounds of radish that are no-tilled after the straw is baled. Manure gets applied right before planting, and then that crop is actually harvested and chopped for a neighboring dairy herd. They get, they're quite happy with the volume of feed that they're getting. They claim about 5 to 6 ton per acre. And you can sort of see that's a large harvester that's running, and there's a lot of material going through. So they've been quite happy with what it's doing, and it works really well for us too because it gets that top material gone, and basically we're keeping all the root mass and the radish there, and they're covering, you know, all the costs are covered by the crop leaving, and they're also the ones putting manure on as well. So it's worked well. It's very, very well for the two of us together. The one neat thing that we did find from that, though, is there. Once we did harvest that, I was amazed that the radish grew back as much as it did. So even though we harvested it, there was still a crop came back and a green right back up, and the radish actually kept growing. So that field there, we actually came back and strip tilled into this past spring, and we definitely learned some lessons. The strip till unit that we rented showed up about a week before we thought it was going to, and you can see that's quite green. If I were to do it again, we'd make sure we had it burnt off. It did create a very mellow seed bed, but we ended up with some insect damage because of all the green matter that everything was feeding on. So following winter barley is something that we do that's kind of unique. You can see in that top picture there's quite a bit going on. So we double crop soybeans back in, so straw is baled and removed. We run a Amazon catchrows over the windrows of chaff. We found we need to bury some of that residue to get a good start. We drill soybeans back in, and we harvest the cover crop with good success. So the guys that buy our straw probably get sick of me sometimes because we're quite often pushing them quite hard to get the straw off. So in that picture, you can actually, up in the corner, there's a baler going. There's guys picking bales up. There's the disc running over, burying the chaff, and the drill's going all at once. So we actually ended up kind of lucking out that night when we finished with the drill. We had 1.5 inches of rain and sort of set things off pretty well. So that was 5 days later. Beans were up and starting to go. So that's about 2 weeks after. Things are greening up quite well. So that would be about the end of July. Soybeans drilled about 300,000 seeds per acre kind of thing. So they fill in quite fast. We cover crops back in with flew barley seed back on top of it again. And there it is there. So that got covered up obviously with the leaves at leaf drop. Right before harvest. So that would be about November the 10th. Greening back up underneath with a harvestable crop. And that year we harvested about the 13th, I think, of November, and beans were 13%. So kind of luck out, we can harvest the same field twice. Kind of a funny thing, combining the same field twice in the same year. So that was New Year's. That year following harvest, everything greened right back up with the winter barley. We were actually trying to, just a curiosity thing, see if we could harvest the same field 4 times in 2 years. So that was right before we ended up ripping it up before planting corn. We gave up on that idea, and we didn't have good enough survivability. It's kind of patchy with some issues with flying the seed on. So that's the sort of the structure of our soil. It's quite mellow, quite forgiving, but not perfectly forgiving. So that's why we've got to watch some of these other issues. Following corn, we apply manure. We do tillage either with the disc ripper on the bottom, and I should sort of do a bit of a disclaimer there. We're not running it the typical depths. We're 6 to 8 inches with it. We're not the 10 to 12 that some run them. So we just find we have better luck. We've got a lot of stones, and running 10 inches, we have a lot more stones. And I don't like picking stones. So our goal for anything that we do, we try to keep 30 to 40% trash cover on top. So then we run that Amazon over the ground going into soybeans the following year. I really like seeing our manure incorporated. I don't like, with all the phosphorus issues in the lake and stuff, I do feel that with the manure we need to do what we can to minimize it, and that's why I like to keep the trash where it is too. So that's actually after the disc ripper runs over. It's quite level, about 30% trash, and if you look close, you can see we're working it on an angle, and I don't know if it shows up very well. You can actually still row every row of corn as well. So it's a fairly aggressive tool, but we're leaving it fairly level on top, and that top bit is undisturbed, which works well for going back in the spring with manure tanks as well, because nobody likes being shaken apart on rough ground. And that's one of the fields following the Amazon with the sort of the disc scenario. That's our cultivator we run things over with in the spring. Nothing fancy, just a S-tine unit. And if you noticed, it's very good at catching elastics. Somebody asked one day when they saw it, so what kind of shank protectors have you got on there? One farm we have came out of vegetables for the past 10 years or so. And if we're catching that many elastics, I'm scared to know how many are actually out there. So I was really shocked how many that thing can catch. Following soybeans, we apply another shot of manure, incorporating using that Amazon. We blend radish seed with our winter barley at a low rate, and the reason we do that is to try to capture some of those nutrients coming out of the manure and carry it over till spring. Barley doesn't take much nitrogen for us to get a good crop, and we're starting to feel that we're able to tie up enough with the radish to tie it over. So we're just planting with a John Deere no-till drill, nothing fancy. There's the radish, November 20th. They don't get very big, but by January 15th they're frozen off. So that's the gist of what we do. That's sort of we're trying a track machine for next year to try to minimize some compaction. It was a goal that we had. There's always been expensive step to make, but we found an auction unit, so we'll see how we like tracks and hopefully reduce some of our compaction a bit more. It'll just, not on a manure tank basis, but just grain cart and cultivator. So that's all I have.
Pretty good for the first time. Thanks, Ian. Awesome job for your first time. Be careful. We'll start getting you out more.